Alrighty, so this is going to be day one of area and perimeter of triangles. So we're like, oh yeah, area, perimeter, we know area of triangles. When I usually ask someone like, what's the area of a triangle? Like our go-to is it's 1/2 the base times the height. And you're like, yeah, that sounds really familiar. That's totally it, which it's true. But the problem with this is that when we talk about this height of a triangle has to be a value that's going to be perpendicular to the base. To figure out that height, it has to be perpendicular to one of the sides. It could be a right triangle like this, and then we automatically know our height. So that's great if you know that value. So this height, also known as the altitude, 1/2 of base times height, that's our go-to. We know that. We were doing this back in elementary. But what if you don't know that height? So that's where we're going to get into these new formulas. So these are true. We can use this as long as we're able to figure out that height. So it's not that this doesn't exist anymore. It does, given certain information. So some other ways to figure it out, if we don't know that height, if we're just working with triangles without knowing the altitude or what that height is, then we could go ahead and we can use what we call the trigonometric area formula. And this works for if you're given a side, angle, and side of any kind of triangle. So it doesn't need to be a right triangle. If you know the side, angle, and then side, so you know the two sides and what we call the included angle of a triangle, then you can use this formula that is 1/2 AC sine of B. So that's the two sides, and then that's the angle in between them. So whatever variables they might be. So here's our trigonometric, they call this the trigonometric area formula, and it's going to be this right here. So that's going to be one new way that we're going to be using. The other new way is what they call Heron's formula. It's right here, but I'll write it up here as well. Heron's formula. So Heron's works if we have a side, side, side triangle. So what that means is we know all three sides of the triangle. Then we're going to want to use this formula here. So the actual formula is this piece right here. This is the actual formula. But there's this other information that's given. That's because there's this variable of S here. We have this idea of S. So it's S, and then it's S minus A. So it's talking about the side of the triangle. This is my other side, and that's my third side. But this value of S is going to be 1/2 of A, B, and C, the sum of them. Or do you know what all of this is? That's just the same thing as saying that S is 1/2 of your perimeter. It's 1/2 the perimeter. So if I add all the sides up and divide it by 2, then that's going to give me my value of S. So let's go ahead and let's use some of this information. So these are going to be the two that you're going to be focusing on today. So this first one says, which triangle area would be calculated using the trigonometric area? So again, we're going to use trigonometric. That's the one where we need to know a side, angle, and side. So trigonometric is going to be this one right here, different than Heron's. So they're calling them by their different names. You need to recognize that. So we're looking for side, angle, side, triangle. Well, when I look at this first one, I'm given a side, side, side. So that's not trigonometric. This one, we could solve the area using our Heron's formula. That doesn't answer the question. This one here, this is a side, angle, side. Notice that it's the two side and it's the angle in between. That's the included angle. This is the one that we could use our trigonometric area formula for. Oh, looks like it froze. There we go. This one over here would be an angle, sorry, a side, side, angle. So it's an SSA. We don't have anything to do with area for that one. And this one was only given an angle and an angle. So we don't know, and we don't have enough information to use either area formulas for that one either. So this one would be trigonometric. This one would be Heron's. These two, we don't have enough information. However, we can use our law of sines and law of cosines probably to figure something out. So let's go ahead and then let's go to our first actual application. All right, so this is awesome. Using Heron's formula, they gave me a little clue of what I'm going to be using already. They told me, calculate the area of the parallelogram to the nearest tenth of a square unit. Okay, so here's the deal. They told us to calculate this entire parallelogram. Well, I don't know. I don't have enough information. I don't know how to do, I mean, there's a formula for area of parallelogram, but they did tell us to use Heron. So they want us to use this idea of triangles. So that's totally fine because I know that if I could figure out the area of this triangle, it's going to be the same as the area on this half. These two triangles are going to be congruent. If it's a parallelogram and I cut it in half using the diagonal, they have to be congruent. So if I just figure out the area of this one and multiply it by 2, then we have the area of our parallelogram. And so that's the route that they want us to go. So using Heron's, first I need to figure out the perimeter of this triangle. So it's going to be 5 plus 8 plus 11, and that's going to be 24. So that gives me the perimeter. I need to solve for S. S is just half the perimeter. So I take my perimeter, which is 24, and I divide it by 2. So S is 12. Then the area of this triangle is going to be the square root. Now remember, it's S times S minus each one of the sides. So it's going to be my value of S, which is 12, times my S, so it's 12 minus each one of the sides. So it's going to be 12 minus 11, 12 minus 8, 12 minus 5. So 12 minus 11, 12 minus 8, 12 minus 5. No, it does not matter which order you put these in. It doesn't matter. You're going to end up multiplying everything together. It does not matter. So I'm going to have 12. 12 minus 11 is 1. 12 minus 8 is going to be 4. And 12 minus 5 is going to be 7. So 12 times 4 times 7, I multiplied them all together. I would just put it in my calculator, which I already know is going to be 336. And I go to my wonderful calculator and I take the square root of 336, and that's going to be approximately 18.33. So I know the area of this piece is approximately 18.33 square units. That means that this one's also 18.33 square units. So to figure out my parallelogram, so make sure you're paying attention to what you're looking for, it's going to be 2 times my 18.33, which is going to be approximately 36. And it says to round your final answer to the nearest tenth, 36.7 square units. And we're done. Do I have any questions? Any questions? This is probably your first time seeing this formula. When I do this, I usually set it up every time I do my P, I do my S, divided that by 2, and then I find that area piece. So you'll see that I usually try to set my things up in the same way every time. And it also helps you remember how to do it. So again, Heron's, you need to know your side, side, side. So we need side, side, side. So that will help you identify if they didn't tell me which formula I would need to use. All right, I'm going to flip. So this next one I actually think is a great problem. So it says, which statement is true about the relative areas of the two triangles? So we have two triangles. Is triangle ABC greater than our other triangle? Is it less than? Are they equal, or we need more information? So basically, I need to find the area of both of these two triangles, if possible, and compare them. Which one's going to be bigger? So I'm going to start with ABC because it's up here first. So I'm going to look for my triangle, area of triangle ABC. So I want to see what information do I have, and I look here and I have a side, side, side. So since I have a side, 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 I would use Heron's. Okay, so if I'm going to use that, then first thing, Similar to what we just did on our last problem, I'm going to figure out my perimeter. P is equal to 7 plus 6 plus 4. So that's going to give me 17. Then my S is going to be 17 divided by 2, my perimeter divided by 2. I'm going to put that as a decimal. I'm going to put it as 8.5 because it's easier to work with. I'm going to end up using my calculator to find the square root anyways. Then the area is equal to the square root of S, 8.5, S minus 4, my S minus 6, and my S minus 7. So each one of the sides, so it's 8.5 minus 7, it's 8.5 minus 6, and it's going to be 8.5 minus 4. So my area is equal to the square root of 8.5 times 1.5 times 2.5 times 4.5. And I go to my calculator and I multiply all of these out. And I get that my area is going to be the square root of 143.4. And I plug that in my calculator. And when I do that, I get that it's approximately 12 and it rounds to a value of 12.0. I don't want to round it to the whole number. You'll see why in a second. So we usually never round to the whole number until the very, very end. If the answer says, hey, what is to the nearest whole number, or your answer choices are all as the whole number, then I would round it then. But as you're writing things out, don't round it to the nearest whole number. That should never be the case. So this is going to be units squared. My second triangle here, I look here and here's a side, an angle, and a side. So this is an SAS triangle. That means that we're going to use our trigonometric area formula. So just as a review, because we haven't worked with that one yet, that formula was A is equal to 1/2 AC, and we said sine of B. Okay, so what do these letters mean? And we don't even have an A, B, or C here. So all it's saying is that these are going to be the two sides and then the included angle, the angle between them. So in this case, it's going to be 1/2 of 2 times 12 times sine of 98 degrees. And I go to my wonderful calculator and I would just put this all in together. So just to kind of show you guys, I would just do 0.5 times 2 times 12. Of course, you could probably mental math that piece, but that's okay. And then I would just do sine of my 98 and I hit equals. And this is going to be 11.9. 11.9 square units. So notice, if I rounded both of these to the whole number, they would have been exactly the same, but they're not the same value. They are not the same value. They're close, they're super close, but if I look here, this one is larger, right? That one is bigger, not by much, but it's still bigger. And so I could say then that my triangle ABC is greater than, so triangle ABC is greater than my triangle. This was my triangle XYZ. So it's greater than my triangle XYZ. And there's the answer right there. So be careful. If you rounded to the whole number there, you probably would get it wrong then, because you would say that they're equal and they're not. This one is actually larger. So you shouldn't be rounding too much. All right. And my last one. So I'm kind of bummed about this because this is another Heron's and I'd like to do another trig area one, but it was also a word problem. So I wanted to kind of be able to show you guys how to work with the words. So just the way it kind of worked out. I think you guys will be fine with this. I'll do more examples of this one tomorrow anyways. So if you guys have questions, let me know. Okay, so it says the spinner of the compass is two congruent isosceles triangles. So that means, see these tick marks? That's saying that all four of those are exactly the same length. So their bases are shown in the diagram. So the base of each of the two triangles is 2 centimeters. So the base here is 2 centimeters. And the legs are 5 centimeters. So each of these are 5 centimeters. If the metal used to construct the spinner costs $13.25 per square centimeter, how much will it cost to make this part of the compass? So we know what the cost is, but how much material do we need? So we need to figure out how much material we need for this whole thing. But I'm going to break them apart into one triangle first, and then I could just multiply it by 2 because they measure exactly the same. And to figure out how much material I'm going to need, I need to figure out the area that needs to be covered. So I want to figure out the area of this triangle. And since I know each of my sides, I'm going to use Heron's again. So if I'm going to use Heron's, then I need to figure out what is the perimeter of that triangle. So it's going to be 5 plus 5 plus 2. So it's a perimeter of 12. Then S is going to be my perimeter divided by 2, which is just 6. Then to figure out the area, it is my value, it's a square root of S, and then it's S minus each of my sides. So it's S, or 6 minus 5. There's 2 of those, so you have to do it for each one of them. Technically, this is values of 1, so when you multiply it, it's not really going to change it, but I don't want you to get in a bad habit and think that you don't need to write it. So it's 6 minus 5 again, and then this would be 6 minus 2. So this is going to be 6 times 1 times 1 times 4, and it's going to be the square root of 24, which is approximately 4.899. All right, so this one is 4.899, but there's 2 of them. We want it for the 2 of them. So I'm going to multiply this by 2, and I get that it's going to be approximately 9.798 square centimeters. So the area of both of these, of this whole thing, is 9.798 centimeters. So that's the area I need covered. Well, how much is it going to cost me to cover it? Well, if it's going to be $13.25 per square centimeter, then I'm going to do my $13.25 times the amount I need, 7.98, and multiply them together. And I need approximately, or it's going to cost me approximately $129.82. So this was $129.82. So again, this is the cost, and this is how much we need. This is how much material. So that's covering the area outlined in the pink. And just multiply them. And that's it. That's all I have for you guys today. We're going to work more with this tomorrow. Again, you're going to need calculators for all of this. Keep them handy. Be easy to do your stuff with it. If you guys have any questions, feel free to message me. And we've got plenty more examples to work on tomorrow and the next day. So if you guys need anything, I'm here for you. Otherwise, you guys have a fabulous day.
Have a good day.
Thanks, Rob. You too.